Right, first of all, we're given two triangles and we're asked to find the transformation that maps A onto B. It's not going to be, so then you've got to think of your four transformations. It's not going to be a translation because it's not the same orientation. It's not going to be a reflection because you can't reflect to give that. Enlargement, well, it's the same size. Sometimes you can actually use, technically you could use a negative enlargement here. I'll come back to that right at the end. The only other one is a rotation. And you can actually see that, yep, if I rotate this, it's going to be on B. It's just where do I rotate it about? And the key to this basically is grab some tracing paper and try some different points. There is logic to it, a bit more logic to that. Like you wouldn't try and use a point over here because it's going to end up, it's going to end up like over here. There's no way you could get it there. So a little strategy is actually to find points where the corresponding points, i.e. this one and this one, are the same distance away from the center of rotation. So for example, it could be here where I put a little X, could be here, could be here, could be anywhere along this line, but it can't be like over here because that's going to be closer to A than to B. So it's just a case of trying some out. And you'll find that if you put it on -1, 0 and move it around like so, then it will perfectly fit on. Brilliant. So it's going to be a rotation. And how much, I didn't actually say, but how much I rotate it by of 180 degrees. Now we do not need to specify whether it's clockwise or anti-clockwise because it could be either. If you do give it one, then that should be fine as well. Rotation of 180 degrees about, you might write center of rotation or you might just write center of rotation -1, 0, or you might just write the coordinate down. Okay, we've now got, we're asked about a single transformation that's equivalent to this reflection and then this translation. So let's give it a go. I'm going to use A, triangle A, to help me with this. So first of all, the line x equals 3. What does that look like? It actually looks like this. It's the line that goes through x equals 3, but all along this line, x is equal to 3. Here, for example, I've got 3 minus 5. I still have x equals 3. So if I then do a, let's not worry about the translation for the second. If I do my my reflection, I go into the line 90 degrees and then I go the same distance. So that point goes to there. This point, I go 1 and 1 again. And then this final point, I actually go 3. So I go another 3 and there we have it. I think it's very hard to do this question without using the grid to help you. So that's my first, after my first transformation. I then do a translation by 4, 0. Now what this means is I move 4 along in the x direction and 0 along in the y direction. So it's going to, so this one's going to go 1, 2, 3, 4. And I basically move the whole shape 4 to the right. There we go. Okay, what single transformation would have done that to start with? Well, it's not going to be a translation, it's not going to be a rotation, it's not going to be an enlargement, it's going to be another reflection. So I just got to think, what line would I reflect it in? And it's got to be halfway between, say, these two corresponding points. So if I count along, 1, 2, 3, 4, 5, 6, it's going to be 3 along, like the midpoint, essentially. I'm going to draw this line. There it is. That will give me the reflection from A to the blue triangle. And that is a reflection in x equals 5,